Hello, this is John from caveofprogramming.com. Welcome to another tutorial on Java multi-threading. And in the last tutorial we looked at wait and notify in Java for low-level thread synchronization. And in this tutorial I'm just going to show you a worked example of wait and notify. So we're going to do producer consumer again, but this time using these kind of low-level multi-threading techniques just to help you get the hang of how they work. So I've got a main program as before, which just runs two threads, and I've got a simple class here with two methods, and my main program runs this method in one thread and this method in another thread. And I'm going to have in this class some shared data between the threads, and I'm just going to make this a linked list full of integers, although it could be, let's say, a linked list full of some complex data class, of course, representing whatever you like. And I'm going to I want a limit to this list because I don't want it to grow without end. So I want to have like some sort of constant here, private final int limit, which I'll just set here to 10 for the purposes of this demo. And my producer thread is going to add items to this list. It's going to add integers to this this shared data store, and my consumer thread is going to remove items from this store. And what I'm going to do is, so here in the producer thread, I'm going to just have an infinite loop just to keep things simple, and I'm going to declare an integer here, int value equals 0, and I'm going to add values to this list as fast as I can. So I'll just say list.add value in this loop, and my consumer thread is going to try and remove values from this loop. So it's going to, while true, it's going to say int value equals list.remove, and I'll do remove first because what I want to do is I want to add to the end of the list, which this does, but remove from the beginning because I want it to be a first in, first out kind of structure. And here I'm going to output the length of the list. So I'll say list size is, and list dot size, and then here I'm going to just output the value that I've got from the list. So I'll say sysout value is and value. And the reason I'm just putting a semicolon here is because I want to get rid of this ln and just have this output all on one line. So I just put that in to make it look a bit neater. What I need now is I need some kind of synchronization. Well, actually, I want to increment this value after I've added it. So I've got a value here. I add the value. Java will auto box this with a integer type for me, even though it's actually an int. And then after I've added it, I will just increment it so we can see some kind of progress. And then the first thing I need is synchronization. And what I'm going to do here is I'm going to declare an object. I'll call it lock, to lock on, because I could use the intrinsic lock or the monitor lock of the processor object itself. But I'm not going to do that here just because I want to emphasize that you need to call wait and notify of the object that you're locking on, which I didn't really emphasize in the last tutorial. So I'm just going to make this explicit this time. And within the loop, I need some synchronization. So I need, let's say, synchronized. I'll have a synchronized block. I'll synchronize on this lock object. So I'm using the intrinsic lock or the monitor of that lock object. And I'll put this code here. The code that actually accesses the shared data has to be inside the synchronized block. And I'll do the same thing here. So I'll say synchronized lock, and I'll put this stuff in here. Okay, now the next thing that's wrong with this is I want to make sure that I only add items if the list is not full, and it's full when it's got this many items in it. And so what I'm going to do is I am going to here say while list.size equals limit, and I'm going to say lock.weight. This is why I'm using this lock object here. It's not necessary, but I just wanted to emphasize that you need to call weight on the object that you're actually locking on. It's really important or it won't work. And why have I got a while loop here? Well, I'll explain in a second, but this is going to wait if the list is full. And in here, if I add an item, I want to say lock.notify, or if I had more than one thread that could be waiting, I'd want to say notify all. So if this kind of goes to sleep if the list is full, and then it hands over control of the lock, and then this will remove an item, and then it will call notify, which wakes up this. And then I don't want to just blindly assume that just because this thread's been woken up somehow that this condition is now false. I want to go round the loop and check it again, and that's why I've got a while loop here. So normally when you use wait, you probably will want to surround it with a loop like this, so you can check that the thing that caused you to wait in the first place, so that you can check that that condition genuinely no longer applies by going around the loop again. And I'll do the same kind of thing in my consume method, because I'll say here, okay, what if the list is empty, if list.size equals 0? Then what I want to do is I want to say again, well, not wait, which wouldn't work at all, but lock.wait, because I'm locking on this lock object. And of course, also when I add an item to the list, I need to call notify to correspondingly this. Of course, I need to call lock.notify. This is going to wake up this thread. Okay, and one last thing that I want to do here actually is within this outer while loop, I'm just going to put a thread.sleep, and I'm just going to make it sleep for some random period of time, which I'll make on average half a second. So I'll have a new random generator here, and Control Shift O to add the import there, and I'll just here say I'll make my thread sleep for random.next int 1000. So I'm saying up to this is going to be milliseconds, and the average value of this, well, this is going to be a random number from 0 to 1000, not including 1000. So the average value of it's going to be, probably 500, hopefully. So it's going to be sleeping on average half a second. So let's run that and see if this works. And you can see that we're counting up the integers, we're not missing any, we're not getting any twice or anything, so the synchronization seems to be working. And the list size, it reached 10 really quickly, and it's just kind of sticking at 10. And the reason for that is, of course, the bottleneck here is this thread here, which has got a sleep in it. So this is limited in how fast it can remove items from the shared data store here. But while this is just going like crazy and trying to add items as fast as it can. Okay, and of course, if I'd forgotten here and I'd started trying to lock or wait on some other object, then I'd run into problems pretty quickly. So don't do that. So okay, that's all for this tutorial, and probably there'll be more tutorials from me on multi-threading if anyone's interested. So join me again in future, and you can find this code on caveofprogramming.com if you want to have a close look at this. So until next time, happy coding.